Welcome to Tech Tips. Today we will explore BHP or brake horsepower calculations. Many ask how useful this formula really is. But once you understand the formula and how to manipulate it, you discover just how versatile it can be. What is brake horsepower? Simply put, it is the horsepower needed at the system requirements. To calculate the horsepower needed, you need to know the system total dynamic head, or TDH, the gallons per minute of the system, and the specific gravity of the product being pumped. In our industry, we essentially ignore this as we are pumping water with a specific gravity of 1. You also need to know the horsepower constant 3960. And finally, the efficiency of the pump. How do you know the efficiency of the pump? Well, often the efficiency is dictated by the customer, for example, an engineer, or an efficiency of your own determination. For this discussion, we will be using 81%. Now we know what the formula is, let's put it to practical use. One question often asked is this: what is total dynamic head? Well, looking at this simple diagram, it is friction losses throughout the system, pressure converted into feet of head, elevation, standing water level, and more importantly, the drawdown. Adding all these factors will give us total dynamic head. So let us look at a straightforward example. We are given the system requirements of 800 gallons per minute and a total dynamic head of 300 feet of head. Remember, we will be using an efficiency of 81%. Doing the math, we calculate that system will need 74.81 horsepower rounded up to 75 horsepower. Now let's prove the results. Going to the sizing program and inputting the gallons per minute and total dynamic head, we see we are in fact pretty spot on. Digging into the output a little deeper, we find the efficiency is in fact 82.55%. Going back to the formula now, using the 82.55%, we see the horsepower in fact needed is 73.41 horsepower, which still rounds up to 75 horsepower motor. Now I know you are asking, why not just use a sizing program? Well, you may not have access to a computer at the time, but if you know the formula, you can quickly estimate the need of a project. Or a customer gives you a questionable requirement, you can quickly discover the scope of the project and maybe rethink the requirements. So how else can this formula be used? Well, you are on site and need to know the head or pressure the pump can produce to test it. You know the horsepower on the nameplate. And you know the system is running 1000 gallons per minute. By now solving for total dynamic head, you will see here how the formula changes. Doing the calculations, we find that the pump should build a total dynamic head of 321 feet. This then gives you the information to do a deadhead test of the pump. Now, granted, the information has been given to us, and we have been able to calculate the head easily. Now let us take the opportunity to use a sizing program and pull up a curve. Reviewing the curve, you can see we are spot on. Will the data given guarantee this is in fact the submersible pump curve of the pump we are testing in the well? No, but we have gained two pieces of information. The first, the total dynamic head to test the pump, and second, the parameters we need to size a new pump should we need to. Finally, what if gallons per minute are in question? Often a system is designed and then a limitation pops it head up. And this is common, that the power authority can limit the horsepower of the equipment to be used. The good news is, again, by manipulating the formula we can solve for gallons per minute. An example, a booster system as designed is needing 400 feet of head but is limited to 50 horsepower. Doing the calculations, the first indicating that it should be achievable. But reviewing the data in a sizing program shows us our best option is still more horsepower than would be allowed. So, we now have a better target number for efficiency. Let's recalculate at a lower gallons per minute. Using the 77.9% efficiency, we can recalculate the flow calculation and discover we should be able to flow 385 gallons per minute. And again, we could then go to the sizing program and see it we hit our target horsepower. In summary, the brake horsepower is very versatile and can help in sizing, troubleshooting, and designing a system. Take the time to learn how to work with this formula is well worth the effort, and can give you a jumping off point before you go to a sizing program to pinpoint the pump needed for the system. Thank you, and be kind to each other out there.